in this video, we'll talk about topic 4.2, where we will focus on stoichiometry. We have two parts and today is the part 1. We'll look into what is stoichiometry and also we are going to do some basic calculation, which is very similar as your mole concept calculation. So, first and foremost, stoichiometry have two requirements before you start to do any calculation of stoichiometry. You need to have a balanced chemical equation. The first thing that you need to have must be a balanced chemical equation. After you have a balanced chemical equation, the second requirement for the stoichiometry calculation is the ratio of the stoichiometry must be in number of mole. You cannot compare in any other form except number of mole. So remember, in stoichiometry, we have two requirements. Balanced chemical equation and the ratio must be in number of mole. So for example, I have a balanced equation over here, 2 aluminium on the reactant, 2 aluminium on the product. I have 6 hydrogen on the reactant, I have 6 hydrogen on the product. I have 6 Br on the reactant, I have 6 Br on the product. So I have a balanced chemical equation. Second, what is meant by stoichiometry and why do we need stoichiometry calculation? Stoichiometry is actually the mole ratio comparison in a balanced chemical equation. For example, I need 2 moles of aluminium to react with 6 mole of HBr. That is from a balanced chemical equation. But if I don't have 2 mole, how do I know how many HBr do I need? Let's say if I only have 1 mole of aluminium, how many mole of HBr do I need? So it's from the balanced chemical equation. We know that 2 mole aluminium requires 6 mole of HBr. So if I have 1 mole of aluminium, I will then need 3 mole of HBr. That is what we mean by stoichiometry. Other than comparing the reactant, we can compare the reactant and the product. For example, 2 mole of aluminium will produce 2 mole of AlBr3. So, if I have 2 mole aluminium, then I will have 2 mole of aluminium bromide. But what happens if I only have 1 mole of aluminium? Then how many mole of aluminium bromide that we are going to produce? Simple. The stoichiometry is 2 aluminium to 2 aluminium bromide. Therefore, 1 mole of aluminium will then produce 1 mole of aluminium bromide. That is what we mean by stoichiometry. We can compare anything in the equation as long as they are balanced. So if I can compare 6 mole of HBr produce 3 mole of hydrogen gas. So if I only have 3 mole of HBr, then how many mole of hydrogen gas do I form? And obviously 6 mole produce 3. So 3 mole then produce 1.5 mole of hydrogen gas. That is what we mean by stoichiometry, and that's why the stoichiometry must have a balanced chemical equation. And the ratio, when you're comparing the product with the reactant or the reactant with reactant, basically when you're comparing anything in the equation, the ratio must be in number of mole. That is what we need in stoichiometry. So let's go into some examples. First example that we have on the screen is I have 1 mole of magnesium react with 2 mole of hydrochloric acid, forming magnesium chloride and hydrogen gas. And the first thing that we are going to do is make sure this is a balanced chemical equation. And if you look at it, I have 1 magnesium, I have 1 magnesium. I have 2 hydrogen, I have 2 hydrogen. I have 2 chlorine, I have 2 chlorine. So, the chemical equation is now balanced. Next, we are going to answer the question. The question asking for the mass of hydrochloric acid juice if you are forming 0.33 gram of magnesium chloride. We are looking for mass of hydrochloric acid. So we have mass of magnesium chloride, which is 0.33 gram. So what are we going to do is, we need to check, we need to make sure we have a balanced chemical equation. Second, the stoichiometry must be compared in number of moles. So to work out the mass of hydrochloric acid used, we need to know the number of mole of hydrochloric acid. But how do we know the mole of hydrochloric acid? Stoichiometry come in. We have the mass of magnesium chloride. We have this. And we know that the relationship between hydrochloric acid and magnesium chloride is 2 to 1. But the requirement in stoichiometry is, when you're doing the ratio must be in number of mole. So we need to change this mass to number of mole of magnesium chloride. Then we can compare the number of mole of magnesium chloride with the hydrochloric acid, and you will find the number of mole of hydrochloric acid. And how can we change the mass of magnesium chloride to number of mole? First and foremost, we need the molar mass. Molar mass of who? Molar mass of magnesium chloride, which is this. Make sure your molar mass calculation is in 1 decimal places. Work it out. And the molar mass calculated is this. And when you have the molar mass of magnesium chloride already, we are going to change the mass to number of mole. We know that 1 mole of magnesium chloride right now is equals to 95.3 gram. And you are having 0.33 gram. So what would be the mole of magnesium chloride? Number of mole of magnesium chloride calculated is 3.4627 times 10 to the power of negative 3 mole. That is the number of mole of magnesium chloride. But we are looking for the number of mole of hydrochloric acid. So what do? From equation, we know that from the balance equation, 2 mole of hydrochloric acid is producing 1 mole of magnesium chloride. And right now, we have 3.4627 times 10 to the power of negative 3 mole of magnesium chloride. What would be the mole of hydrochloric acid? So the number of mole of hydrochloric acid calculated will be 6.9254 times 10 to the power of negative 3 mole of hydrochloric acid. And that is the number of mole of hydrochloric acid. But the question asking for mass. So what do? We find the molar mass of hydrochloric acid. Molar mass of hydrochloric acid, simple, which is 36.5 gram per mole. And we know that mole ratio of hydrochloric acid and molar masses. 36.5 gram is when you have 1 mole of hydrochloric acid. But what would be the mass when you have 6.9254 times 10 to the power of negative 3 mole of hydrochloric acid? What would be the mass? So, when you solve the ratio, you know that mass of hydrochloric acid calculated 0.2528 gram. And that is the mass of hydrochloric acid calculated. So what do we mean by stoichiometry is this. From the equation, we know that 2 mole of hydrochloric acid produce 1 mole of magnesium chloride. So when you have the number of mole of magnesium chloride, you can find the mole of hydrochloric acid. And from the mole of hydrochloric acid, you can change it to mass of hydrochloric acid. And that is what we call stoichiometry. Very simple. As long as you have a balanced chemical equation, you will be able to find this. Let's move to the next example. So in this example, we'll talk about volume in room temperature and also number of mole. So a student carry out an experiment at 25 degrees Celsius, 1 atm. So we know that when the temperature is 25 degrees Celsius and 1 atm, that actually represents room temperature pressure. And you have 48 grams of ethane. So you have C2H6 right now is 48 grams. is completely burned in excess of oxygen and producing carbon dioxide and water. So you're producing carbon dioxide gas and H2O water. First question say balance chemical equation for the reaction above. Second, we need to find the volume of carbon dioxide gas produced. So we are looking for volume of carbon dioxide gas. And since it's a volume, that's why we need the condition. First and foremost, let's write the balanced chemical equation, which is this. And we know that this will be in gas, oxygen will also be in gas, forming carbon dioxide gas, forming H2O liquid. So how many carbon dioxide? 2 carbon dioxide and 3 water. What else is not balanced? Oxygen. You have 4 oxygen over here, you have 3 oxygen over here. So total is 7 oxygen. Therefore, your oxygen will be 7 over 2. So that is your balanced chemical equation. In the second question, we need to find the volume of carbon dioxide. So the relationship between carbon dioxide and also the ethane gas is 1 to 2 ratio. But we know that in stoichiometry, we can only compare them in number of mole. So what do? We need to change this mass to number of mole. So we change it to number of mole and we can get number of mole of carbon dioxide. And then we change it to volume. So let's start. If you are having mass and you want to change it to number of mole, we need to first find the molar mass. Molar mass of ethane gas. And we know that carbon is 12, so we have 2 carbon over there. And hydrogen is 1, and we have 6 hydrogen over there. So the molar mass calculated is 30 gram per mole. And we know that that is the mass of 1 mole of C2H6. That is 30 gram. And right now, you have 48 gram of ethane. How many mole? So number of mole of C2H6 will then be 1.6 mole. And that is the number of mole of C2H6. And from the equation, because now we are looking for the carbon dioxide, from the equation we know that 1 mole of C2H6 will be producing 2 mole of carbon dioxide. And we don't have 1 mole, we are having 1.6 mole of ethane gas. And therefore, how many mole of carbon dioxide? Obviously, number of mole of carbon dioxide calculated will be 3.2 mole. But that is only the number of mole. Question asking for volume. So we know that 1 mole of any gas at RTP is equals to 24 liter. And that is 1 mole. Right now, I have 3.2 mole of carbon dioxide. How many liter? So volume of the carbon dioxide calculated will be 76.8 liter. And that is the volume of carbon dioxide calculated under RTP condition. Simple. It's still the same thing. Whatever the question gives to you, we change it to number of mole. From the number of mole, we use the balance equation to work out the stoichiometry. From the stoichiometry, you find the number of mole of what the question asking for. And then you change it to whatever the question wants. It's either volume, it's either masses. Next, so in this question, still a combustion, but we have different thing. We have propene over here, and the condition is different. It's 273 Kelvin and 1 atm. And I have volume of water vapor given, and carbon dioxide is produced. So what's the question is talking about? When I burn propene, I will have water vapor form, and also I have carbon dioxide gas produced. And right now we know that 273 Kelvin and also 1 atm is actually standard temperature pressure. And the question saying that volume of H2O given is 8.75 liter. And the question is asking for the balance equation, and also the volume of propene burned. So we are looking for volume of the propene is how much. First and foremost, let's write the balanced chemical equation. So I have C3H6, which is a gas, burned in excess of oxygen, forming water, vapor, which is a gas, and also carbon dioxide gas. So how many water do I need? 6 hydrogen. So I need 3. 3 carbon. So I need 3 carbon dioxide. How many oxygen? 3 times 1, 3 oxygen. 3 times 2, 6 oxygen. So total, I have 9 oxygen over here. Therefore, oxygen will be 9 over 2. And that is our balance equation. And the question is asking for the volume of C3H6, but the question gives you water. And that is the relationship of this question. As we all agree, as we all know, the ratio of the stoichiometry must be done in number of mole. So we need to change this to number of mole of H2O. And since it's a volume and is under STP condition, we know that 1 mole of H2O under STP will give rise to 22.4 liter. And right now, we are having 8.75 liter. How many mole of water? So the number of mole water calculated will be 0.3906 mole. That is the number of mole of water. But the question asking for volume of propene. So from the equation, 1 mole of propene C3H6 will produce 3 mole of water. And right now, I have 0.3906 mole of water. How many mole of propene is produced? Solve the ratio and the number of mole propene obtained is 0.1302 mole. And that is the number of mole of propene. But the question asking for volume. And volume is under STP. So we know that 1 mole of propene under STP will again be 22.4 liter. And right now I have 0.1302 mole of propene. So how many liter? And when you solve the ratio, you realize that the volume of propene calculated is 2.9165 liter. And that is the volume of propene calculated. And if you realize we are actually doing the same thing, we change what the question gives in liter, we change it to number of mole. And then we use the balance equation to compare what we have with what we want. So we are using what we have to find the number of mole of what we want. And then we change it to whatever the question asking for, whether it's mass or volume. So let's look into the last example that we have today that involves concentration. And if you read the question, below is the reaction between acid and bases. So we have our acid and we have our bases. And obviously, if you look at our equation over here, it's not balanced. That's why the first question is to balance the equation above. So let's try to balance the equation first. And the balance equation looks something like this. And we are going to use inspection method over here. We have learned inspection method previously, so you can work it out, or else you can watch the video of the inspection method balancing equation again. And the balance equation for this question will look something like this. And everything will be balanced. Now, let's look at B. Calculate the volume of 1.5 molar sulfuric acid. So what the question gives you right now is the molarity of the H2SO4. The molarity given is 1.5 molar. We are looking for the volume of sulfuric acid because the question asking for volume. And last but not least, the question gives you mass of KOH used. The mass given 0.75 gram. So what we are going to do, as always, we are going to change this mass to number of mole because we are going to compare the KOH given with the sulfuric acid that we are looking for. So that is our stoichiometry relationship. But we know that the stoichiometry can only be done with number of mole. So we are going to change this mass to number of mole. Since it's a mass, first and foremost, we need the molar mass of KOH. So the molar mass of KOH will be 39.1 with oxygen 16 and hydrogen 1. Make sure it's 1 decimal places. 56.1 gram per mole. And that is only the molar mass. We have the mass given 0.75. So from the mole ratio of mass and molar mass, 1 mole of KOH will give you 56.1 gram. And now I have 0.75 gram. How many mole of KOH? Number of mole KOH calculated if you solve the ratio above, 0.01337 mole. And that is the number of mole of KOH. So we are going to compare the mole of KOH and sulfuric acid. So from the equation, we know that 1 mole of H2SO4 will then react with 2 mole of KOH. And now I have only 0.01337 mole of KOH. So how many mole of sulfuric acid is needed? Number of mole of sulfuric acid calculated from the ratio is 6.685 times 10 to the power of negative 3 mole of sulfuric acid. But the question asking for volume. And how can we find the volume if we don't know the condition? We can find the volume straight away from the number of mole if we know the condition. But right now, we don't know whether it's STP or it's actually RTP. The question didn't give you, so you cannot use this. But the question gives you molarity. So write out the formula of molarity. We know that molarity is equals to number of mole of your solute. Make sure you remember this from your previous lesson. Over volume of solution in liter. And from that, we can find the volume of solution. Because we have the molarity 1.5 given. The number of mole calculated is 6.685 times 10 to the power of negative 3. And from that, you can work out the volume of solution calculated. But the volume of solution calculated will be in liter. Press your calculator and you can work out the volume of H2SO4 needed, which is 4.4567 times 10 to the power of negative 3 liter. And I will leave the answer in liter because the question only asking for volume but didn't insist on the milliliter. So you can leave the answer in liter. From the balanced chemical equation, you will then be able to know the stoichiometry ratio of each compound in the reaction. And from that, you can work out the stoichiometry ratio. And you can find anything as long as you know one thing from the equation. You can compare anything and you will be able to get it. The rest of the calculation will be more on the mole ratio concept. Whether the question gives you mass, you find the number of mole, or the question gives you volume, you find the number of mole. Or we can use the formula of molarity. So when the question gives you concentration, you can use the formula molarity to find the number of mole or to find the volume. But first and foremost, it's still about the balanced chemical equation and the stoichiometry between the reactant and product from the balanced chemical equation. And that's it for this video. I'll see you again in the next video.